Okay, so this is part 2, and really it's just a review of everything that I had said in part 1, and this won't be such a long video. At least I'm hoping. I start talking and then I just start talking. Alright, so we were talking about hemostasis actually has two major parts. We have primary hemostasis and then we have secondary hemostasis. Now, what you need to remember is that as soon as I have started the clot formation, I automatically am putting in a way to dissolve the clot. And so we actually have a third portion, and that was fibrinolysis. Can you see that under there? Yes. So you can see fibrinolysis. So we have primary hemostasis, secondary hemostasis, and fibrinolysis. All right. As a review, primary hemolysis consists mainly of my reaction of my blood vessels with my platelets, the initial adhesion of the platelets. Platelets are going to get more involved in secondary, but we have this platelets as primary. All right, so the blood vessels, wacko, I get a cut or something. My blood vessels are going to constrict automatically, and when that happens, they're going to be able to release the collagen. They've got elastin and the endothelium. They will secrete some tissue factor also. All right, so primary hemostasis, blood vasculature or blood valve vasoconstriction, and then the platelets. The platelets right here is the beginning part of adhesion. Adhesion is going to go to aggregation and then consolidation. You also need to remember that primary hemostasis is very rapid, but it is short-lived. If for some reason my platelets don't stay adhered and they don't aggregate, then it's going to go off and everything stops. All right, now I also mentioned some of the things that you need to remember with, like mucocutaneous bleeding, etc. And so here we can have chronic hemorrhages. When we have chronic hemorrhages, it's a defect in my primary hemostasis. And I also mentioned it could be something with my blood vessels, such as maybe I have abnormal collagen. Or maybe there's something wrong with my platelets. I have thrombocytopenia, decreased platelets, or maybe I do have enough platelets, but it's a qualitative platelet disorder and my platelets aren't working. Maybe they're missing my glycophorin, or I'm missing receptors, whatever, or maybe I don't secrete my granules. So lots of different things I could have with qualitative. And then I did mention von Willebrand's disease. Now we always abbreviate with a little v and a w. VW disease, von Willebrand's disease. All right, so again, primary hemostasis. Yes, you have to know what's part of primary hemostasis: vasoconstriction and the platelets. And it is fast, but it is very short-lived. So, because it's short-lived and it's fast, the longer way is to have the secondary hemostasis. So with secondary hemostasis, what's involved in secondary hemostasis is going to be your coagulation factors. Now remember, they're enzymatic reactions, but they don't circulate in active forms. They are inactive when they're circulating, so we have coagulation proteins, and there's a bunch. Make sure you look at your tables and your boxes. Make sure you look at that. That's going to give you the names of all the coagulation proteins and which system is it involved in, etc. And the other thing with secondary hemostasis is that the end product of it is supposed to go to thrombin. The end result is thrombin. The next step thrombin does need to go to fibrin, and then it makes the nice clot. And then we've got to get rid of the clot. And here we go, clot formation. So we're going to have fibrin here, thrombin to fibrin, and then fibrinolysis, we need to remove the clot at the same time. All right, so that is your primary hemostasis and your secondary hemostasis. Now, I also mentioned that my blood vessels have a normal anti-clot forming properties. And so I'm going to list, let me see, I'm going to list 7 different ways that my endothelium, my normal functioning endothelium, is going to work as an anticoagulant. Okay, now remember, I'm not using anticoagulant like the EDTA and stuff like that. Anticoagulant just means against coagulation. So my normal endothelium is going to have properties that are against normal clot formation. And so I'm just going to move this camera over this way a little bit, and hopefully you're going to be able to see that. I'm hoping. Whoops. It fell into a hole. I'm sorry. Okay. So, 7 properties. And again, you have your notes. So these are in your notes, and you can just kind of follow along with me. Hopefully you're going to print them out. The anticoagulant properties of a normal, healthy endothelium. Number 1, it secretes prostacyclin. Well, what in the world is prostacyclin? Prostacyclin is a platelet inhibitor. So you can see if my blood is going here and woohoo, I'm a platelet, I'm going to go poof, and I'm just going to bounce off of it because I'm not going to stick. Remember, what was the first series of the platelets that have to come here? First, it's platelet adhesion, then it's aggregation, and then we have consolidation. All right, the normal endothelium will also secrete nitric oxide. And I put NO for no, 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 you're not going to stick, right? No, 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 nitric oxide. Normal endothelium also secretes heparin sulfate. Well, what in the world is heparin sulfate? It's heparin, just like that liquid stuff. What color top tube is heparin? Is it green? Okay. Heparin sulfate. All right, normal endothelium will also secrete tissue factor pathway inhibitor. So what? Remember, tissue factor is needed in order for all of this to work together. So a normal endothelium secretes tissue factor pathway inhibitor. It's also known as extrinsic pathway inhibitor. Well, what's extrinsic pathway? Well, we'll get into that later. We have an intrinsic pathway, extrinsic pathway, and a common pathway. So there are actually 3 different pathways where all of your coagulation factors, etc., work together. Okay, the normal endothelium will also express protein C, and we'll get into that again later, protein C receptors. So I have protein C receptors. So if protein C is circulating, it can attach to my endothelium. Well, I thought we weren't supposed to make clots. Well, that's the thing about protein C. Protein C is an anticoagulant, meaning against coagulation. All right. It also expresses thrombomodulin. Well, what in the world is thrombomodulin? Well, we'll get to thrombomodulin in a little bit. But remember, what is my end product over here? My end result is thrombin, right? But this is to make a clot. But we're talking about anticoagulation properties of the endothelium. And it expresses thrombomodulin, which is going to help chop up any thrombin if it's there. So actually what I'm going to do is kind of erase this a little bit so I can draw something out here for you really quickly. So if this is my hole, my clot, and I've got clots forming, and remember what I need to end up is with thrombin. Over here on both sides is normal endothelium. And so part of normal endothelium has got protein C and it's got thrombomodulin. These are here just in case if a piece of clot comes out and wants to go downstream, my normal endothelium has receptors for here to stop that from happening, and it keeps it localized. So remember, that's what we wanted to do. We want to keep our clot localized. All right, so it has thrombomodulin, and I'm going to explain all this in better detail. Has thrombomodulin, and the number 7 thing that it does is it secretes tissue plasminogen activator. Well, what in the world is tissue plasminogen activator? Okay, so when we went to fibrinolysis, down here, this is incorporated in the fibrin, so tissue plasminogen activator helps activate fibrinolysis to occur. So if anything happens downstream, my normal endothelium is going to have tissue plasminogen activator in order to get rid of it. So isn't that amazing? It's just amazing on how my body will naturally keep my clot localized. And we'll go into that in a little bit more detail later. But how does it help do that? Normal endothelium has 7 different ways that it can help keep the clot normalized, or keep the clot in its area and prevent any other clots from, or I should say, prevent any thrombus. Remember, thrombus is a pathologic clot from happening by secreting prostacyclin, secreting nitric oxide, secreting heparin sulfate, secreting tissue factor pathway inhibitor, expressing protein C, and expressing thrombomodulin on the vessel itself, and it can secrete tissue plasminogen activator, which helps dissolve fibrin clots. Isn't that amazing? It is truly, truly amazing, and how all of this works together. Okay, so this was the normal. Well, what happens if it's damaged, right? So if it's damaged, let me come over here again. So let me kind of erase this here. What's going to happen if it's damaged? Well, right, if I have my, right, and these are my cells, endothelial cells. And I have a hole, right? Or I got a hole there from, let me turn this way. Hopefully. You see that? If I do this, it's gonna fall in the hole again. Hold on, let me see. I closed the hole up. Hopefully that'll be all right. All right, I think you can see that. Okay, So this is my endothelium and it's got a hole. So in other words, it is damaged. I have a damaged endothelium. Now, when it's damaged, it has procoagulant properties. Procoagulant properties. Procoagulant properties. Again, procoagulant means I want to make the clot. I am for. If you say, I am pro something, I am pro coagulating, something I want it to happen. Remember, normal endothelium has anti-coagulant properties, the 7 I just went over, and now this has procoagulant properties. Okay, so what are the properties that are pro? Well, number 1, we've already talked about vasoconstriction. So it's going to have vasoconstriction. And what was the other thing we talked about? Collagen. Collagen. Collagen is exposed when we break up our blood vessels. So we've got collagen that's there. Okay, so what happens is with the collagen acts to bind and activate my platelets. Oh, let me use another color. It binds and activates my platelets. All right, so collagen. So platelets love collagen. They love collagen, right? Okay, so that's like me. What do I love? Oh my gosh. I like potato chips. Anyway, platelets love collagen. It's like Dr. Torres's potato chip. You see potato chips, she's gonna be like, potato chips. All right, platelets, they see collagen. They go like, collagen. And they want to stick. All right, now, the other thing that I keep mentioning is that von Willebrand's factor. So the other thing that we have is von Willebrand's factor. So von Willebrand's factor, where does it come from? Well, it comes from, now I'm going to write it down because I always mess it up. It comes from Weeble Palade bodies. All right, well, where in the world did the Weeble Palade bodies come from? Okay, those come from when your thrombin is activated. Okay. Now, why do I need the von Willebrand's? Why do I? I was out of camera. Why do I need the von Willebrand's factor? I need the von Willebrand's factor so that the platelets can hook onto it. Okay, so in order for my platelets to get hooked on, I need my von Willebrand's factor there. Okay. Now, the other thing that they have is P-selected. All right. So with that, what it does is promote platelet and white blood cell binding. So we want this, again, so that my platelets can come over and help be bound to everything. Okay, so the cells are going to be secreting this. It is an adhesion molecule. So this is an adhesion molecule. What that means is it's going to make the platelets stick together or help it stick together. Now, we also have some other molecules that are secreted, and They are not antibodies, they're not immunoglobulins, but they're, oh, can you see that? Yeah, you can see that. Okay, so they're immunoglobulin-like. They're not immunoglobulins, but they similar to it, but they're not. Okay, so these are called ICAMs. So we have a secretion of ICAM. So what is ICAMs? ICAM stands for intracellular adhesion molecules. So this is actually a little s. Okay? Intracellular adhesion molecules. Well, what do I need adhesion molecules for? I need adhesion molecules for my platelets. All right. And the other thing it secretes are pecans. Not like the nuts, pecans, right? These are PE-CAMs. All right. So PE-CAM stands for platelet endothelial cell adhesion molecules. Okay. So the ICAMs are for just adhesion molecules. The PCAMs, again, for platelet endothelials. All right, and then the seventh factor that it has is tissue factor, which I've mentioned before, tissue factor. All right, so tissue factor is exposed. So I'll put that in a different color. So I've got my tissue factor being exposed. Okay, so my tissue factor is being exposed there. When tissue factor is being exposed, it activates my coagulation proteins. Okay, so that needs that. How does it activate it by? By reacting and contacting with factor 7. Now, coagulation factors are always using Roman numerals. So if you don't remember your Roman numerals from 1 to 13, go back and practice it. Google it or whatever. Roman numeral number 1. Roman numeral number 2, etc. from 1 to 13. Okay, because those are what we're going to be using. If you give me a regular number 7, rather than giving me a Roman 7 of a V and 2 letters, 2 I's there, or ones, that's a 7. All right, always Roman. So tissue factor activates 7. And then you'll see later on how that becomes important. Now, in a pathological type of situation, having your tissue factor is kind of precarious. Because in inflammation, my monocytes, etc., carry tissue factor. So if I have too much inflammation, I could possibly be activating my extrinsic pathway through factor 7. All right. It also happens in sepsis. So it's very precarious, and you have to really know and remember that in large amounts of inflammation, I'm going to have tissue factor. In a sepsis, I'm going to have tissue factor. These tissue factors can activate my factor 7, which may start a pathologic coagulation which could lead to a DIC. So that is really, really important for you to remember that I could possibly have a pathologic situation that is bad. Again, pathologic we're meaning as a bad thing. Okay. Now, all right, so we talked about the endothelium. See how important the endothelium is. The endothelium has anticoagulant properties, and when it's damaged, has procoagulant properties. Now, over here, let me see, let me turn the camera a little bit. Okay, so over here, I mentioned that the endothelium can secrete tissue plasminogen activators, right? And this particular portion right here is going to help in my fibrinolytic system, okay? So, not only does the endothelium have procoagulant properties and anticoagulant properties, it also has fibrinolytic properties. So over here you have to remember, I don't know, did you see me draw that? No. Alright, so what I did was, all I did was put a red box around my fibrinolysis. Alright. And again, as I mentioned, when I make a clot, I'm automatically incorporating ways to dissolve the clot. And some of this has to do with your plasminogen, etc. The other fibrinolytic type of activity is it secretes your plasminogen activator inhibitor. So over here, what I am going to do is use this. Oh, that's already blue. I'll use orange, I guess. And then I'm going to put in here fibrinolytic properties of endothelium. And it's that one, and okay, there are two. That's number one. And then number two is that it secretes did I put that there? Oh, okay, secretes plasminogen activator inhibitor. Plasminogen activator inhibitor, PAI, and that's a -1. Okay, -1. Plasminogen activator inhibitor. Okay. There is another plasminogen activator inhibitor, and that's called the TAF, and that's another one there. Yes, you can see that there. All right, so, wow, that is like a lot of stuff. So you can see. And then I didn't really get involved very deeply in how this happens, but already you can see, oh my gosh, I have to remember nitric oxide and heparan sulfate and prostacyclin and collagen and von Willebrand's factor. You can see that all of this is actually working together to help my system keep in the balance of my coagulant or procoagulant and anticoagulant to make sure that I am staying healthy. And also at the same time, if I happen to get a break in my blood vessels and I happen to make a clot, I have ways to actually keep it localized so that it doesn't move off to other areas and be a pathologic problem and give me strokes and etc. So that was it for the first section of, I kind of call it my intro. And the next thing I'm going to be talking about is your platelet function. Now that one is in a PowerPoint, so I'll be doing that, but I already sent you copies of the PowerPoint slides in the whole section of where it says my notes. Alright, so please, I know that you guys have a lot of stuff, but please, you need to start reading your book, and do not wait until the last minute to try to study these things. Alright, so bye now.